Hello friends, in this video we will be learning exponential, continuous as well as discrete time signal. Let us begin. So let us start discussing about exponential time signals, continuous as well as discrete. So here we will have exponential continuous time signal, and here we will have, let's say, exponential discrete time signal. In exponential continuous time signal we have already seen this signal like e to the power, let's say, 80. Now, depending upon the value of a, we will get either exponentially rising curve or exponentially decaying curve. So let me just take some a greater than 0. It means a is positive. In that case, if I plot e to the power 80 curve, at t equal to minus infinity, I'll get 0. At t equal to 0, I'll get it 1. And at t equal to infinity, you'll get infinity. In effect, you'll get this kind of curve, which is called as a positively growing curve or rising curve. So this is rising exponentially, and whenever a is less than 0, see, a less than 0, it means a is what? It is negative. So if a is negative, let us write minus a. In that case, I can write e to the power minus 80. So we know that e to the power minus 80 is decaying exponentially curve or exponentially decaying curve. Again, I'm going to concentrate on three values of t. That is, if I substitute minus infinity, we know that I'll get infinity. If I substitute t equal to 0, I'll get e to the power 0 as 1. And when I substitute t value as positive infinity, it will become e to the power minus infinity, and anything raised to minus infinity is what? 0. So I'll be getting this kind of curve. Here infinity, here I'll get 1, and here I'll get 0. So I'll get this kind of curve. So this is what we called as exponentially decaying curve. So here I'm getting decaying curve. So I can write in general x of n equal to, let's say, alpha to the power n, where alpha is some constant. Okay, let alpha equal to 2. So I'm taking some random values. Okay, alpha equal to 2 I'm taking. In that case, I can write x of n now as 2 to the power n. And now let us start plotting this 2 to the power n curve. So we can have n equal to 0, n equal to 1, n equal to 2, n equal to 3, or minus 1, minus 2, and so on. So let us start with n equal to 0. So when I substitute n equal to 0 in 2 raised to n, it becomes 2 to the power 0, and 2 to the power 0 will be 1. So here what I'm getting is 1. Is that right? Then at n equal to 1, it will become 2 to the power 1, which will become 2. So higher than 1, I'll be getting 2 here. At n equal to 2, I'll be getting 2 to the power 2, which will become 4. At n equal to 3, I'll be getting 8, like that. So this is 4, this is 8, then I'll get 16, and so on. Right? Let us go on having some negative scale values. At n equal to minus 1, 2 to the power minus 1 is 1 by 2. So 1 by 2 would be again less than 1. So like this. Then for n equal to minus 2, I'll be getting 1 by 4, and so on. So now if you see carefully, it is rising exponentially. As you can see, this is rising exponentially, right? But unlike continuous time signal, we know that n belongs to integer values. Similarly, we can have another value of alpha, and then we will compare and we'll again come to the conclusion here. Let us assume value of n as 1 by 2. In that case, I can write now x of n as 1 by 2 raised to n. Is that right? So let us go on plotting this curve. Again, I'll take n equal to 0, n equal to 1, n equal to 2, 3, minus 1, minus 2, minus 3, and so on. At n equal to 0, half raised to 0 will become 1. So here I am getting 1. Then at n equal to 1, it will be half raised to 1. Half raised to 1 is half. So exactly half of 1. So I am getting 1 by 2. At n equal to 2, I'll be getting half raised to 2, which is 1 by 4. It is exactly half of 1 by 2, and so on. So I'll be getting 1 by 8, and so on. At n equal to minus 1, if you substitute half to the power minus 1, you will get 2. Is that right? So for n equal to minus 2, you will get 4. And again at n equal to minus 3, if you plot, you will get minus 8. So what you see here, you see a negatively decaying curve. Is that right? Or a exponentially decaying curve. So here, what I got? Exponentially increasing, and what I'm getting here? Exponentially decaying curve. So here, always remember, in first case, I got alpha equal to 2. So whenever alpha value is more than 1, you will always get exponentially increasing curve. And here I have taken n equal to half. So whenever alpha value is less than 1, I'll always get exponentially decaying curve. In fact, for negative values also this is valid. So I can say in general, mod of alpha greater than 1 gives you exponentially increasing curve, and mod of alpha if less than 1, it gives you exponentially decaying curve. So you have to remember this, the fundamental difference between exponential continuous time signal and exponential discrete time signal. Thank you.